22nd, and we have been solving some circuits where the supply voltage will be time varying, and as well as there will be energy storing elements in the circuit. And we have considered RL circuit, RC circuit, first with DC sources, and then the basic steps will be write down. If you are interested to find out the current flowing through an inductor, first develop a differential equation involving that current, and note down the initial conditions, that is I 0 minus, which will give you I 0 plus or I 0, which will be same in general. Therefore, then you write down the differential equation, but after that do not integrate to get the solution. See, in our last few lectures I wanted to stress upon this point. If the differential equation is known, you should straight away write down the solution of the differential equation, which will have a natural response part. That is, if the right hand side was 0, no excitation, what would be the solution? That solution depends upon the characteristic roots, and exponential terms will appear there, of course, with some constants, and there will be another solution corresponding to forcing function or excitation present. One important thing to be noted is this forcing function solution alone will satisfy the natural response. So, we considered several problems. Today, I will consider another problem and show you how to apply the same technique when the excitation is a sinusoidal voltage. Okay. For example, consider an RL circuit, RL series circuit, RL series circuit excited from a sinusoidal voltage source, sinusoidal voltage source. And so, the thing is like this: R here, inductance in series L, and here is a source which is time varying, V t is the voltage source, and I 0 minus, this is the current I want to solve, I as a function of time, and I 0 minus is equal to 0, it is suppose given, which was open for a long time and so on. Now, this switch S is closed at t equal to 0. Then how the current will grow in the circuit or will flow in the circuit as a function of time, this I want to find out. Then the first step is to write down the voltage drops, that is R I here with proper polarity, and this is L d I d t. And we know this, that the sum of these two voltages L d I d t plus R I is equal to your input V t. Now, let V t, the applied voltage, is V max into some sin omega t, suppose. So, applied voltage is sin omega t. That means, I have closed this switch. Suppose if I sketch the supply voltage here, this is the voltage I am applying, this is your V max, and this axis is omega t, okay, and this is 0, pi, etc. So, I am closing the switch, this axis is omega t, means also t, omega is constant supply frequency. So, this axis also determines the time axis in some other scale divided by omega. So, at t equal to 0, I am closing the switch. So, I am closing the switch at this point, S is closed at O, and that is why I am describing this as V max sin omega t and I want to get the solution. So, let me be systematic, rules I know, what should I do. So, this is equal to V m sin omega t, is not. Then I will write it first as divide by L, d I dt plus R by L into I is equal to V m by L into sin omega t. This is the differential equation. What is the characteristic equation? Characteristic equation is d plus R by L into I, d is d dt is equal to 0. If you do, you get the characteristic equation, is not, and d is being an operator. So, characteristic equation is m plus R by L. It is a first order system, only one characteristic equation, only one energy storing element. So, m is equal to minus R by L. Therefore, the solution now comes the interesting part. The solution I will write straight away. It will be equal to some constant a into e to the power m t, that is minus R by L into t. That will be the first part. And the second part will be, as we know, the it should be, since it is V t, it should be like k 1 v plus k 1 say bar, k 2 another constant v dot plus k 3 another constant v double dot and up to infinity. This is the solution due to forcing function. So, solution due to forcing function is a linear combination of the excitation and its higher order derivative. Now, here this you see it is sin omega t. So, it should be, if you do this, so you have to go on differentiating this sin omega t. So, this will give rise to, which I am not going to write. What I am telling, it will be some constant into sin omega t, if you put this, plus if you differentiate this, it will be omega cos omega t, is not, that omega I will multiply with k 2 bar to give you another constant. Then if you differentiate v dot to get v double dot, so once again sin omega t term will come. So, alternatively the terms will be sin omega t cos omega t, sin omega t cos omega t, of course, with different constants here, and that is to be added up to infinity. Now, therefore, it looks like there will be terms like, so this is equal to a into e to the power minus R by L into t, plus it looks like there will be sin omega t, a number of infinite number of sin omega t terms. So, whatever it is, I will call that thing to be some big constant into sin omega t, is not. This I can always do, because those coefficients are constant. Similarly, there will be infinite number of cosine omega t terms, and that I will group those. If you take cosine omega t out, this will be another constant term. Of course, C and D will have that omega terms, but omega is constant, not circuit parameter, decided by supply frequency, that is all. But this will be the solution. So, you see I get the solution of this network, the form of the solution, at least I do not require any time. Okay. Find out the characteristic root, this is the natural part, this is this part. Okay. Now, if you wish, I was writing it as some big k 1 and k 2, okay. Generally for forcing function the constants I was writing as k 1, k 2, you can do that. Now, to find out k 1 and k 2, first I will find out k 1, k 2. So, this is the this part solution due to forcing function and this part is natural solution. Got the point? Now, to so this forcing function alone satisfies this equation. This solution, this part will satisfy this, will satisfy alone. Because total solution satisfies this, but natural response if you substitute this will give rise to 0. So, I can very well say except T alone will also satisfy that. That is the key of this whole thing. So, I will put this here. So, it is d I dt. So, forcing function alone will satisfy this. So, it will be k 1 omega cos omega t. I am differentiating this d I dt. So, k 1 omega cos omega t. Then minus I have to differentiate this also. So, k 2 omega sin omega t, cos omega t if you differentiate it gives you negative term, is not, that is okay. So, this gives you d I dt plus r by L into this current due to forcing function, which will be equal to k 1 sin omega t, k 1 sin omega t plus r by L, because r by L is common into I, r by L into k 2 cos omega t, and I am telling this will be equal to V m by L sin omega t. Is not it? This is the thing. This is the thing. So, I am determining first the constants k 1, k 2. K 1, k 2 can be determined and as I told you, so there are two unknowns, not infinite number of unknowns, and these two unknowns can be solved for by having two equations. So, and this is an identity, mind you, this is an identity. Therefore, coefficient of sin omega t on both the sides will be equal. So, what is the coefficient of sin omega t of both the sides? It will be sin omega t terms are here. This is a sin omega t terms, this is a sin omega t terms. Therefore, since it is an identity, I will write r by L into k 1 minus omega into k 2, and on the right hand side there is a sin omega t whose coefficient is V m by L, must be equal to V m by L. That is what I am telling. This is one equation. and the second equation is coefficient of cosine omega t equate. So, it will be omega k 1 this one, and another cosine omega t term is there, plus r by L into k 2. I hope signs are all okay na. This must be equal to, there is no cosine term here, must be equal to 0. These are the two equations I have to solve. So, these two equations I have to solve. Only thing it is Vm, that I will write. So, previous two equations are this one. So, I have to solve for them. So, from this equation I will say that k 2 is equal to, from this equation, r by L k 2 is equal to minus omega k 1 and it will be L by r. This is k 2 and this thing I will submit it, put it there. So, I am going to find out k 1. So, it will be r by L into k 1 was there from this equation minus omega k 2. So, it will become plus L omega square by r into k 1, and that I am telling is equal to V m by L. So, so this is the thing. Therefore, k 1 will be equal to V m by L in the numerator, and below it will be r by L plus omega square L by r, is it? This thing I have brought it down, which will be equal to V m by this L you bring down, it will be equal to r, L cancels out, plus omega square L square divided by r, and this r also can be put out on the top. So, r into V m, it will be equal to r square plus omega square L square. So, this is the value of k 1, and if this is k 1, then k 2 is minus omega L by r into k 1, and k 1 is this one r V m by r square plus omega square L square. So, r goes and you will be left with minus omega L divided by r square plus omega square L square into V m. This will be the thing. Therefore, the solution, total solution will be I t will be equal to A into e to the power that minus r by L into t, that is the natural response, plus solution due to forcing function. So, k 1 into sin omega t, and k 1 is this one into sin omega t plus k 2, which happens to be a negative thing like this. So, omega L by r square plus omega square L square into V m into cos omega t. So, this is this total solution. Only thing is, this can be manipulated a bit and it can be written in this form, that plus this one, and here what you do, you take V m by square root of r square plus omega square L square common from these two terms, then you will be left with r over this thing sin omega t and minus omega L, and V m I have taken outside, 1 square root I have taken. So, another square root also is left here, cos omega t. It will be like that. Now, these two things you see, this term square and this term square gives you 1, is not? This square plus this square, they will give 1. Therefore, I can define let R by I am sorry, I will do it here. So, R let R I defined as R by root over R square plus omega square L square as cos theta. And then omega L by this one same square root has to be sin theta. Why? Because this square plus this square is 1. Therefore, this equation, so this is cos theta and this term is sin theta. So, I have sin omega t cos theta minus cos omega t sin theta. Therefore, this solution is nothing but a into e to the power minus r by L into t plus V m by this quantity, and this one can be written as sin of omega t minus theta. Got the point? So, this is I t. This is the solution. Now, in this solution still A is to be determined. Capital A has not been determined yet. Mind you, after you write down the total solution, then you apply the boundary condition. For example, A is to be determined from boundary conditions. Which is given to be I 0 minus equal to 0, that is equal to I 0. So, I put that and find out the constant here. So, here there is space, I will do here that thing. So, put t equal to 0 on both sides. So, it will be equal to 0 is equal to I 0 is equal to A e to the power 0 is 1, and in this expression t is equal to 0. So, it will be plus V m over root over r square plus omega square L square sin of minus theta. What is theta? Theta is tan theta is equal to, as you can see, I have defined cos theta sin theta. So, tan theta is omega L by r. So, sin theta is known in fact. Therefore, A will be equal to V m divided by root over r square plus omega square L square. Sin minus theta is minus sin theta. So, this becomes plus then if you change side. Got the point? So, this is the value of A. Therefore, total solution I will write in the next page as so total solution for I t, I mean I want to get the solution t greater than equal to 0 will be equal to I t is equal to some e to the power minus r by L into t plus solution due to forcing function V max over this thing into sin omega t minus theta, and here the value of the constant was found out to be this thing V max by this into sin theta. So, this constant is V max by root over r square plus omega square L square sin theta. Mind you, theta is constant. Once the circuit is known R, L, and your supply frequency is omega, then you know and we are solving for this current, and we know that tan theta is equal to omega L by R. So, this will be the complete solution. Let us see whether this solution is okay or not. At t equal to 0, I 0 must be 0. So, at t equal to 0, this is B m by this into sin minus theta, and it is V m sin theta by this. So, sin minus theta is minus sin theta. So, these two terms will cancel out and will give you the result. So, this is the total solution. Got the point. So, if you sketch, as I told you, it is always better you sketch the solution. So, sketching for the solution you should do it like this. First sketch V t. This one is V t, which is equal to V m sin omega t. Here is omega t. And then the current waveform is this kind of thing. See, if you look at this current waveform, it has got two distinct parts. One part is V m by root over r square omega square L square sin omega t minus theta. So, theta value is known from this. So, current waveform will be lagging the voltage waveform by an angle theta. I am drawing it with red. This is the solution due to forcing function. This part is this part. Got the point? Only this part I have drawn. Then there is a part, but this is the only IFT, but there is a natural part. You have to add this waveform to this to get the total solution. Now, what will be that part? That part is telling that this one, the magnitude at t equal to 0 of the forcing function is minus V max by root over r square plus omega square L square sin theta. Sin minus theta minus you bring outside. So, at t equal to 0, this is the current, negative current. But at t equal to 0, this must give this much of positive current, and in fact, it is given. So, this I will use a different color, yeah. So, it will, this length is equal to this length, these two lengths are same, and this one is at t equal to 0 V max sin theta by root over r square plus omega square L square, and then it is exponentially decaying, is it, e to the power minus r by L, and the sum of this curve plus this curve will give you the total current. Therefore, initially this sine wave, after some time, of course, it will be only this part present. After sufficient time means talk in terms of time constant of the circuit. After sufficient time, only this term is present, this term alone will be present. Since B max sin theta, the other term by root over r square plus omega square L square into e to the power minus r by L t will tend to 0. That is what it is. After 1, 2 or maybe 3, 4 cycles, it will be only black and red curve will be present. Of course, initially this current waveform will start, has to, if you try to draw the resultant current below. So, this is I will write, it is fair to write. So, this I f 1 and this I will write, this blue one is natural response I n t. So, the total current will be sum of this, and it has to start from 0, and then this plus this, this plus this, this plus this. So, here it will grow like this, some asymmetry will be there initially, then that thing once again will fall, it will be like this, here it will be 0, I mean something like that you get, then this is vanishingly small, I mean something like that. So, initially there will be asymmetry, it will be shifted, it is called DC shift, and then of course, after a long time what will remain is this voltage waveform black and this red waveform I n t will vanish. So, this part is this is the total solution, and we find in the total solution there will be a transient part which will decay, and this part is called steady state solution. This is also called solution due to forcing function, is also called steady state solution. And this is called the transient part. Got the point. So, what is the conclusion? See, behind all this mass, the conclusion is to be understood very carefully. The conclusion is, any RL circuit you suddenly switch on with the help of a switch, then the response of the current will comprise of two parts, but sum of these two at t equal to 0 has to be 0, that is there, it has to start from 0, and there is an exponential term which will appear, and that will go down to 0, and finally, it is the steady state solution which will sustain. Any switching of RL circuit with some sinusoidal excitation, a transient will be born, but that transient will not last long, it will die down. Die down by what time? Well, it depends upon the time constant of the circuit. Maybe after few cycles that transient will be altogether vanished. That is why while analyzing AC circuit, say RL, RC, this type of circuits, you energized with sinusoidal, people often neglect this transient part. I am interested because with see one supply cycle 50 hertz is the supply frequency, 20 millisecond is one cycle. RL values are such that the order of time constant will be of the order of some few milliseconds, maybe 3 cycles, that is 60 millisecond, maybe if it is very inductive. But after that 60 millisecond, only this fellow and this fellow will be present. Who bothers? That transient was there when you switched on the circuit. Of course, this initial current which is produced, which is sum of transient and the steady state current, natural and forced response, these are very important piece of studies in power system. When you energize a power circuit line having lot of inductance, then initial current surge may be more. And last point I want to make it, behind all this maths you should not forget this. For example, let me tell you which I am not doing, but I must point this out. So, to create interest, for example, you have a supply voltage like this. This point you listen carefully. This is omega t. No maths here. V max sin omega t is the voltage I am counting time here. Now, the point is this supply voltage is present like that between two, say your supply cord to supply, it is supply is present and it is doing like this. Should I call it sin omega t or else? Depends upon me. If I start counting my time from this instant, I will say okay, it may be called cosine omega t and so on. But what I know for certain is that the steady state current will be doing like this. This I can draw. Red one is the steady state component ISST, which is equal to I forcing function t. I just did last time. So, circuit the steady state current is very simple, you know that V max by Z root over R square plus omega square L square is called impedance into sine of omega t minus theta and this is theta, is not. Now, what I am telling, I am not going to do any maths, but I am telling you one very interesting observation. This if you understand, I will be happy. I mean, you can do several things. For example, I say that I have an RL circuit here, I am going to energize it with this switch and I will close this switch. What is the supply voltage? Supply voltage is doing like this. I have not yet called where is t equal to 0, but I will tell that when I close this switch I am not really sure, because I cannot see the supply when I switch on, say your fan in your home, you switch on, you do not, it is after all some sort of RL circuit. Anyway, I may switch on when the supply voltage was maximum, when the supply voltage was 0, it is left to chances, I do not know really. Now, suppose I say, in the previous problem I told you, I have closed the switch when the supply voltage was 0 and going towards positive. And then I will tell but current through the inductor cannot change instantaneously. So, steady state demands this much negative current is flowing. So, this much of positive current must appear to make it 0, and that will be the transient part. That way I can now imagine how things are going. Suppose I say that with this I will say this is your supply voltage. I am not writing omega t equal to 0 etcetera. Okay, this is your supply voltage, but steady state current will be displaced from it by an angle theta. This angle is not, this is the steady state current red one ISS. Now, suppose I say that I will close the switch at this instant when the supply voltage was around this point. Okay, here also there will be, we expect some transient to come and that will die down. But what will be the value of the transient current right at this, if this is the switching instant? You close the switch when it was doing like this at that point. But current through the inductor cannot be 0. Steady state demands that the current is this much positive. Do your maths the way I did, but I am telling you, believe me, there will appear a negative current of same amount. Here lies the catch. This and this two will be equal, and this current will decay down to 0. This will be the nature of the transient. So, behind all these mathematical steps, getting the results, one can easily write down the steady state part of the solution, which is very easy to write, sin omega t minus theta. From that, decide at whatever time you switch on the circuit, you make up what is. We will continue with this in the next class. Thank you.